Let's say we have a circle cut up into 4 pieces, and then we have another circle, but this time this one's cut up into 8 pieces. Technically speaking, we can add these two things together, but it makes it a little hard to do. So what we can do is we can break this one up into eighths, and then we can count how many eighths that we have. So when we're adding or subtracting fractions, it helps to make the denominators the same. In fact, you might do this for all the problems that you come across. So let's take 1/4 and 3/8. So how can I solve this? Well, 4 is a factor of 8. So what I can do is I can just convert this fraction into something to get a denominator of. So what I can do is I can multiply this fraction out so I can get a denominator of 8. So what I'm going to do is I'm going to multiply it by 2/2. And the reason we're allowed to do this is 2/2 is the same thing as 1. So we're essentially just multiplying it by 1, and it doesn't change it at all. So then, if I multiply this by 2/2, I get 2/8. And this is the same thing as 1/4. If we go back to our pies, if we have 2/8, that's the same thing as 1/4. So now we have 2/8 plus 3/8. And since our denominators are the same, we're just going to bring that denominator over here, and we're going to add across. So 2 plus 3 is 5, and our answer is 5/8. Now, let's say we have a problem like 2/3 plus 1/5, where we can't multiply 3 to get 5. When we come across something like that, we have to multiply both sides by something that they share in common. So something that both sides share in common would be 15. So to get 15, what I'm going to do is I'm going to multiply this side by 5/5. So then I get 10/15. And then I'm going to multiply this side by 3/3, and I'm going to get 3/15. And then I can just bring that 15 over, and then I'm just going to add the top, and I'm going to get 13/15 as my final answer. So when you're adding or subtracting fractions, there's this option where you multiply one fraction, or there's this option where you have to multiply both of them to get a number that is common with both of them. And the same thing works for subtraction. So let's take 2/3 minus 1/5. Let's multiply these by 5/5, and this one by 3/3. And then I get 10/15 minus 3/15, if I bring the 15 over, 10 minus 3 is 7, and that is my final answer. So essentially, if I have any number, let heart represent any number. And let square represent some other number. This could be 1, 2, 3, 4, -1, anything that we want it to be, but we just don't know what it is, right? It's any number. Same thing here. So what if I have 3 over heart plus 4 over square? These are any numbers that we want them to be, but we don't know what they are yet. So if I want the denominators to be the same, I'm going to want to bring this square over here, and then I'm going to want to bring this heart over here. So what does that look like? Well, I'm going to multiply this by square over square, because the goal is to get the square over here, and then right here we're trying to get the heart over here, so that way they can both look the same. And on this side, I'm going to multiply it by heart over heart. So then what I end up with is I end up with 3 times the square, because we're multiplying fractions, over square times heart plus 4 times heart over square times heart. And then since these are the same, I'm just going to bring that over, and I'm going to get square times heart. And 3 square plus 4 heart. And that is my final answer. We don't know what square and heart is yet. They're just placeholders for some random number, but if we did know, then we'd get answers like these up here. Alright, here are some practice problems for you guys to do, and as always, I'll leave the answers at the end of the video.